Hello guys, in this video I'm gonna show you how to implement the 2x1 multiplexer in Vivado, VHDL in Vivado. So we're gonna follow the exact same steps that we did in our tutorial of VHDL in Vivado, like that we published maybe 2 weeks ago, except for the last step, not the last step, in the writing step, because of course we are now implementing a different circuit. So we have we should have a different code. Okay. So I'm gonna show you two ways actually to do the multiplexers, the 2x1 multiplexers. The first one is basically what we studied or what we saw in our last video using the truth table, okay, and if else statement. So we count the number of zeros in the truth table in the output, and we count, and if they are and they count the number of ones, and we choose the lesser, the one that's appear less in the output, and build our code according to it. In that case, unfortunately, here we have 4 zeros and 4 ones, so we can go with whatever you want. I'm gonna go with the ones this time. Last time we go with the zeros, now we're gonna go with the ones. So we're gonna implement these cases: second case, fourth case, and seventh and eighth case. Okay, so we need a process. If you're gonna go if and else, we need a process, and our sensitivity list here is our inputs S, D, and D0. Now for the f, it's very simple. Like for example, the first f here, if s equal to 0, and the d equal to 0, and the d1 equal to 0, and the d0 equal to 1, which is this case here, 0, 0, 1, then z equal to 1. Let's get another case for it, like the last case. If s equal to 1, and the d1 equal to 1, and the d0 equal to 1, then z equal to 1. So you have here 4 lines because we have 4 ones, else z will be equal to 0, or we're gonna assign 0 to z. Okay, that's one way to do the circuit. There is another way, and maybe you can use it like in other circuits if it's like similar for you, which is basically the sum of product of any function. Is basically you look at the ones and do the sum of product. Very simple, very simple. Like for example, we know from our sum of product theory, if you have a truth table, since the output here should be like the summation of 4 terms. This term, which is S complement, D1 complement, D0, or the sum, or the complement of S0, D1, D0, then the last 2 terms, S, D1, D complement D0, S, D1, D0. That's basically what I did exactly here. So this is another code here. It's in gray. I don't know, I'm not sure if you can see it well, but you can maybe zoom in or something to see it. So the first term is not S, which is complement, not D1, and D0. That line here. Let's highlight them so you guys can correlate. Second one, this guy, or not S, complement S, then D1 and the D1 and the D0, because D1 and the D0 are ones. Okay, or the third one here, S and D1 and not D0, because D0 is complemented. The last one, there is no complement at all, so or, don't forget the or, S and D1 and D0. Okay, the third one here, D0. Okay, that's also very correct. You can do whatever you like. You can do this one or this one. I advise you, because this video is like showing the result for this one, I advise you to do this one as well. Okay, I didn't do the simulation for it, so like 99.9999 it's gonna be correct. But if it's not, just let me know. Okay, so try to do both. Start by this one, then do this one. Okay, let's now see the simulation. As I told you, I followed exactly the same steps that we did in the last video. Okay, so I already did that everything, and here's the simulation. Okay, of course, I make a force clock for S, force clock for D1, force clock for D0. We need last time we have like 4 inputs, so we need for this 4 inputs 800 nanosecond. Here we have 3, so we have half because this is binary. So 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Each time we double. Okay. So for each extra input, you double the period. So we have 4. When we had 4 inputs, we have 800 nanosecond total simulation time. When we have 3 inputs, you divide by 2. So you're gonna have 400 nanosecond. As you see, D0 here is alternating 0, 1, 0, 1. So look, the 0, 1, 0, 1, 0, 1, 0, 1. This is the highest frequency. I made the frequency, the period of the frequency or the signal 100 nanosecond. So 0 and so look, this is one period from 0 to 100. You can, because one period means you have like everything. You have the 0 and you have the 1. Another period, another period, another period. Okay, so 4 periods represent 8 values 0, 1, 0, 1, 0, 1, 0, 1. Then D1 here has a period of 200 nanosecond. Okay, because it goes like 0, 0, 1, 1, 0, 0, 1, 1. Finally, for the selection, the S input, we're gonna have a period of 400 nanosecond. Okay, so you have 100, 200, I'm sorry, 100, 200, and finally 400. Every time you go, you multiply by 2. So you have 0, 0, 0, 0, 1, 1, 1, 1. Okay. And look at the Z here, the output. I already run the simulation. So here is the output Z. Okay, if we go with the yellow bar. So when everything is 0, we got D0. D0 is 0, so Z is equal to 0. Still, S is 0, the selection is 0, so we should choose D0, or the output should copy D0. D0 now is 1, so the output is 1. Then we have still the selection is 0, but D0 came back to 0, so the output is 0. Still the selection is 0, so we still have to select D0, but D0 now goes to 1, so Z become 1. Then the selection of 1, so we should choose D1. D1 is 0 here, so Z is 0. Selection is 1 again. Again, D1 is 0, so again, Z is 0. Here, finally, the selection is 1. The second input here, D1, is 1, so the output is 1. And finally, again, finally, S is 1, D1 is 1, and still, because we're going to copy the D1, so we still have 1 on the output. Okay, guys, that was it for the lab. Thank you very much for watching, and see you in another video. Bye.